In this lesson, we'll start to operator overloading. Okay. In Python, we have some methods to be used in class implementation in order to overload some mathematical operations for each instance. Okay, there are many operators such as for example, for the plus operator, add, or r add, or pos. These have the functions to be used in what the operator overloading mechanism in the Python programming language. And so, if you have any class in here, and so this class can be specialized by using or writing this function. And so we can add the two class variable in here, or mul and rmul can be given in here. And so we have another operators within a list, and just like this one. Okay, I can copy of the whole of these things in terms of the operator overloading, and so we can write these values or implement these values or these functions in order to specialize or increasing the features of the class. But how we can do that? Firstly, in order to understand that, we need to create the example sessions x1 for the number. For example, we want to create the number class in here, just like this one, that init self number can be assigned, and number is self number is equal to the number. Okay, so x number can be created with these parameters. Okay, see this way. And so also just remember that we can specialize our str function body in here, the self. We can return to returning the str values of the self number. Okay, see, this is the self number. So the print x can be written in here 10, but we can specialize also the other numbers in here. For example, if you want to implement the addition operator with another variable x, and so we can return to the new variable of the number self number plus x number can be built in here, just like this one. Okay, this is the add operator. Or we have sub operator in here, minus value. We have the mul operator, multiplication operator, just like this one. Okay, or the true division self x and return the number of the self number divided by x number. Okay, so you can define the number 20 and z is number 2. Okay, k is equals to x plus y times z. What is the result of the print k in here? What is the result? Yes, 50. See? 50. And so how we can be sure about that this formula is given in here? For example, we can print what the information about this class, just like this one, the add and sub and mul and division. Okay, and so if I rerun this code, just see that we multiply first these values, and after that we add the x value into the what, into the k values in here, just like this one. Okay, but what about this one? X is number a, y is number b. Okay, z is equal to what? X plus y. And so the print z. What is the result of this code right now? Which part you can't understand, Bara? Just tell me. It's right. This order is given in here, just like this one. And so if I rerun this code, we have the multiplication operator in here, y times z plus x, and so we multiply firstly in this case, and so the result of these terms is assigned to what? The add operator in here, and so we can read what? The 50 value. This is the answer I provided you, but okay. And so what is the output of this code right now for the second case? If you rerun this code, and then the AB is seen on this page, right? And so this A can be considered as the variable, but the plus B returns to the what? The str value, or string value. Okay, and so if this is a number, we need to specialize our number class in here. You understand that? Otherwise, we can collect the whole two str term in here, just like this one. The add is calling in here, but the only see this add, this can be string and this can also be string, and so two string can be combined in a one variable word, right? Because we don't have any integer type or the double type or the boolean type in here. And so how we can be sure about that this number is a number in mathematics? This is the case right now. We should specialize this function based on this information. Okay, and so first of all we need to specialize our function in here, class numbers. Okay, and so def init can be called in here, and so we need to give the put the what? The number. Okay, so this pass is removed, and so the if is instance. What's the meaning of the is instance? Anyone remember that? Anyone? We can check the data type. No. We can check the data type of the what? The number. For example, if we have the int and float value in here as a tuple can be given, and so the self number is assigned to the number, because we know that this number is in the terms of the what? The integer, either the float value. Else we need to give the warning. The print number must be what? The positive. Okay, in this case, for example, x is equals to the number, and so this can be assigned to the a, and so if I run this code and then see that this number class cannot generate this value, number must be positive, or the arithmetic numbers. See, we can't permit to what? to generate this number as a string or the other values in here. Okay, or we can use the denominations also in here, just like this one. We can give the true values in here. The true number must be arithmetic. Okay, but why we see to what one warning in here? Can anyone say that? Yes. And so in order to remove this condition, the book can be given in here, but the number is to what is returning to the one values in here. Okay, you must know that we have the conversion method in here, but we will talk about it later. Okay, so what about this one? This is the constructor, and so that that self and x can be given in here, and so we need firstly control the what variable type x, and so integer or float value. This can be checked, and so after that, if this is the true, we need to generate what a new number, self number plus x. Okay, otherwise we need to return to the what, the number, self numbers plus x in numbers. What is the meaning of these terms right now? What's the difference between this value and this value? Can anyone say that? Yara? Mara? See, if the x is given in the integer or the float value, and so we don't need to create what another number parameters in here, because this is not an instance of the number class. Okay, for example, if we derive the what, the 1, and y is number 2. Okay, so to print, we need to also give the str function in here. The str self should be given in here in order to write the values of these terms, the str self number. Okay, and so print x plus 1. Okay, see, that's the 3, because 1 and 2 are given, but which value is calling in here? The print is instance true. Okay, if this is the case, and so see that why we only see the 3 value on the terminal, because its instance x is int and float value is given in here, just like this one. Okay, why this print is not printed on the terminal? See, in the second case, so we can print what, x plus 11. If we rewrite this code, and so voila, is instance to add is seen on the terminal. But what is the difference between these two variables in here? You must say that. in the first place, we have the two number classes variables in here. Okay, this is the number and this is the number. Okay, and so if this is the case, is instance x. X is not a true int or float value. X is in the type of the number, which means that you cannot use this by. This returns to the what? To the false. After that, the number is reaching with the what? The x dot number and self number, because the x is in the type of the number. Okay, number class. But in the second case, x plus 11. See, and so this 11 is assigned to the what? To the x. Is instance 11 is in the range of the what? The int and float. This is true, and so self number plus x can be called in here because x is in the type of the integer value. Okay? Okay. So we need to write another functions in here. The sub self x. So if type x is int or type x is float, we can write also this function instead of using the is instance. Okay, and so we need to return to the what? The number of self number minus x, guys. Okay, otherwise we need to return to the what? To the number self number minus x number. Okay, see, these are identical with this one. Or def move self x if is instance x integer value or float value, and return number of the self number times x, because the x is in the type of the integer or float value. Or return to the number of the what? The self number times x number, right? X number. See? So how we can write the true division? Self and x. Firstly, if is instance x is in the type of the integer or float value. Okay. Firstly, we must check the x is not equals to the 0. But why? 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 Runtime error, yes, thank you, Mara. And so, if this is not the case, we can freely divide the self number with what? With the x. Otherwise, we should print that the number must be non-zero, right? And we should return to the empty space. See, and this is our condition, and so we can prevent any runtime error based on this class. The operator overloading is useful to what? To design your class with the basic or with the specific features. See, if we write this true div operator in here, and so we cannot divide the sum number with the 0. We prevent everything based on this class definition, and this is useful, right? Else, if the x is the instance of the number, okay, and so we should check that if x a number is not equals to the 0, and so we need to return to the what? The number of this term self number divided by x number, right? And else we should give the print the number must be non-zero. Okay, and so we should give the return. And after that, this is the first case, 10 and 20. Doing here and z, x divided by y. And so, what is the result of the R discard right now? What's the result of this card? Yeah. See? 0, that's 5. But y is equals to the number 0. What is the output of this code right now? Yes, number must be non-zero. And returning to the what? To the none. Because the z is equal to the none. Okay? Okay? So, we can write our own number classes, just like this one. For example, we can build the rational class. Rational number class. What's the rational number, guys? What is the rational number class? Can anyone say that any rational number? Could you write me? Rational number. Does anyone know rational? No, it's not a 2. For example, 1 divided by 2. This is a rational number. No, this is a float number. No, don't. This is the rational number. Okay? So, for example, 1 divided by 2, or 3 divided by 2, 2 divided by 3. Okay? This is rational number. But if you write the this one, 1 divided by 2, automatically Python converts this value into the what? Into the float one. But I want to see 1 divided by 2 at this case. Okay? This is our specialized class. And so, class rational can be defined in here. See the def. First of all, the init function. We can assign the a0. This is the default arguments, and b is equal to the 1, because at the initial case we don't have any part with the values of the 0 at the denominator. Okay, and so we need to check if not is instance a integer or not is instance b integer. We must give what integer value at the rational number, because we need to create a number with the what? With 2 integer values. 1, 2, 2 and 3, right? This must be always be integer value, because it's rational. Okay? And so we need to raise the type error in here with the what? The numerator and denominator must be integer. Okay? And also we need to give the what? The b. If equals to the 0 and raise to what? The value error right now. Denominator must be non-zero, right? If this is not the case and self A is assigned with the A and self B is assigned to B, and also I can give one more function, the simplify function, in here. Okay? What's the meaning of the simplify? Simplify is the special function for our algorithms. Simplify self can be defined with this one, ECE, math ECE can be called in here, self A and self B can be given, and so the self A integer equal GCD, and self B integer GC. Okay, this returns to the what? To the values of this A and B in terms of the integer value. Okay, GCD, greatest common divisor operator. Okay, and so we can write every integer. For example, if we have to what, the 4 divided by 8, right? We can write the 4 divided by 8 or 1 divided by 2. This is the GCD operator utilization. But do you understand right now? You can write the 4 divided by 8 or 1 divided by 2. GCD is used to what? To have the greatest common division operator in here. We can simplify the R algorithms or the rational number based on this information. But you get it? Okay. So after that, we need to give the def repar self. Okay. So if self B is equals to the 1, and so return str self A, because if the self B is equals to the 1, this is the integer number because A divided by B is given in here, right? Let's see that A divided by B, and so if the B is equals to the 1, it's equal to the A, right? We need to give that. But this is not the case, and so if self A is equal to the 0 value, we should return to the what? To 0. But what? You see that this is the case of the what? A divided by B, and so this is equal to the 0 divided by B, which is equal to the 0. Do you understand that? You understand? Yes. And so if this is not the case, we need to give the functional operator with the what? The self A must be given with the what? Self of B. We should return it. Okay? So how we can write the add and another function? Def add self R can be given in here if this instance R integer value and so A is equal to the what? R times self B plus self A. The denominator self B times R plus self A gives us to what? To numerator. B is equal to the self B. Okay? This should be kept with the same. And so self A times RB plus self B plus times RA, and B is equal to what? The self B times RB. Okay? This is just what? The add operator on the what? The two rational number. This is simple. And so we need to return to the what? The rational with the initial value of A and B. Okay? So R add is assigned with the add function, because the add function is the same with the R add in here. It's the reverse. This is no. Okay. So what about the self operator in here? Self R. If this instance R integer value, and so A is equal to what? R times self B minus self A, right? This is the rule, the mathematical rule. And self B can be assigned in here, and else A self A times RB minus self b times ra. Okay, and b is equal to the self b times rb. And also we should return to the what, the rational a and b. And after that our sub is equals to the what, the sub. If we write this overload, and so we can assign this overload instead of the r sub. R sub is the another parameters in here, just like this one. And also if the def mode self r, if is instance are integer, a is equal to what, the self a times r. The numerator must be multiplied with the r, and b should be kept with the same. After that, the else can be given in here a self a times ra, and b is a self b times rb. Okay. And after that, we need to return to the what, the ratio, with the same idea based on the previous examples. And so our move should be assigned with the move. We can assign this function name into the another. Okay. What about the true division? True div self r, if is instance are integer value, a is self a and b is self b plus no times r, because the division should be calculated in here. Else a is self a times rb and b is self b times ra, right? And so we need to return to the what, the rational a and b, right? And also our true div should be assigned the true div. Is this complex for you guys? Okay, but before creating another parameters, we need to give some examples in here. We can define the rational 3, 2 and y rational 1 and 2. Okay, and so the result x plus y, okay, x plus y, and I assign it in here. And so we can print the result. What is the result in here? What is the result? See, if we have this information, we have 2, but why? Just see that this rep r function is given in here, just like this one. Because 3 divided by 2 is given in here, and 1 divided by 2. Okay, this simplify function is called in here with these nominations in the rep r. Okay. So what about this one? What's the result of this code? Oh. See, just now we have 3 divided by 3, right? 2 divided by 3, because the simplification cannot be done in here. Because in every case, just see that the rational is recreated in here. For example, if we have these informations, we just see that 3, 2. In order to understand the calling functions in here, just see that we have the 1, but see the print constructor can be warned by this one, and so the rep r constructor b equals 1, right? And after that, constructor b not repar b is equals to 1, okay? And after that, the simplification operations can also be given as a warning in here. Simplification, okay? After that, the add must also be given. So if I rerun this code, just see that the constructor is created and the simplification is called. After that, the constructor is created for the y, okay? And the simplification is applied to the y, okay? And so after that, the add operation is called, and also constructor and simplification, and then rep b is equals to the 1 is given here, which means that this rep r is called in here just like this one, not this rep r, yara. Do you get it right now, yara? Okay, so but if we put the first case, the 1 divided by 3, 1 divided by 3, see, the normal repar is called. So the true RDIV is defined in here, but what about the other parameters in here? The LT can also be built with this case, self R, okay? And so if is instance R int, so if this is the case, return self A divided by self B is smaller than R. Okay, return self A divided by self B smaller than RA divided by RB. What is the purpose of the LT in here? Yara, can you say that? We control the what? What's the purpose of this code? Def LT. Can anyone say that? Okay, just see that the return value returns to the what? To the Boolean operator. Self A and self B is smaller than R, which means that this is the lower part, right? But we have also add another functions in here, LE. This is another overload, but with basic difference equals to, okay? This is the equals. Okay? We can compare the R algorithms in here, just like this one. LE lower equal. Okay, what about this one? We can copy all of these terms in here, and so we have the GT and GA. What's the difference? The GT, this is the lower control, this is the lower and equal control. What about the greater? The greater. So this must be rewritten as the what? The greater symbol. But in the second case, the greater and equal should be given in here, just like this one. We can check the what? The two rational number. which is to a bigger or smaller than the previous one. Okay? If this is the case, and so what about this one? If x greater than y, for example, the print x is bigger than y, right? We can write it. So, see, x is bigger than y is given in here. But what about this one? 3. See, we don't have any properties in here, just like this one. Else, the print x is not bigger than y, right? See? And so, what is the purpose of this code right now? Yara, can you tell me? Can anyone say that? Yes, returns to true or false, but you need to understand that if this is the case, and so print lt false, print le false, print gt false, print ge false. Okay? See? GT calls at this case because we control what the bigger part of this. This is the what the conditional operator overloading based on the class variables. Okay. So what about this one? And so if this is the case, we can write the what to these values ge, not the h. What's the meaning of this term? This is equals to what? The equally, right? So equals, and this returns to what? To this one. Okay. We can compare this algorithm based on this one, and so we can check also not equal conditions and e, right? See? What about this one? If this is the case, and so we also get what the equal. And so if I run this code, see equals equality control system. R is the another variable. For example, if we call this x and y in here, x is bigger than y, this can be rewritten just like this one. This is identical. See, x dot gt y, and so in this case this is y is equals to the r. See, Yara, these two terms, this one and this one, is identical. So if this is the case, and then we can check also this one. See, and equals gt equals and gt equals in here. And so what about this one? We have also more function. We can create a conversion method function. Return self A, self B, right? For example, if we have this property, and also we can create the integer value, just like this one. Okay, or we can convert the bool self and return self A is not equal to the 0. Okay? These are the conversion methods. But how we can use these functions? Print, float, print, int, print, bool. Okay, and so the z is equal to the what, the bool y, for example, or integer. And so if I run this code, see, we just called what integer function, but int is called in here because this overload gives us this value, the bool x, for example. See, the bool or z and float. What about this one? 1, 1, 1, and so this float is assigned to x plus y. Okay, and also we can print the z in here. See, the last term calls the float overload in here, and so this float turns this rational number into the z float value, just like this one. Okay. Now, do you understand that, guys? Okay. This is just like building to your own integer values or integer functions. Okay.